In this video, we evaluate the integral of x by 1 plus x by 1 plus x square is exchanged from 0 to infinity. We will do it by substitution method and using property of definite integral. We let I equal to this integral that we want to evaluate. We want to do it by substitution method. Observe that if I let x equal to tan theta, then this expression can be written as sec square theta and it gets simplified. Let's assume x equal to tan theta. Let x equal to tan theta. When I let x equal to tan theta, then 1 plus x square is sec square theta. How about the limit? When theta equal to 0, x equal to 0. And when theta increases from 0 to pi by 2, x increases to infinity or x tends to infinity. So we can write integral as I equal to integral from 0 to pi by 2. 0 to pi by 2. How about x? Instead of x, I can write tan theta. Instead of x, I can write tan theta. Instead of x, I can write tan theta. Rest of the expression we can copy as it is. 1 plus copied, 1 plus copied, square copied. How about dx? You see that when I let x equal to tan theta, then I can differentiate both sides with respect to theta to say that dx d theta equal to derivative of tan theta, which is sec square theta. So I can write dx is sec square theta d theta. Once again, I can write dx is sec square theta d theta. Wow, we can see that we get a much simpler expression. That's because 1 plus tan square theta is sec square theta and we can cancel sec square theta out. Let's do it. Okay, let's write tan as sine by cos. We write tan is sine by cos. Tan theta equal to sine theta by cos theta. Once again, tan is sine by cos. Tan theta equal to sine theta by cos theta. 1 plus copied as it is, d theta copied as it is. We are integrating with respect to theta. Now we multiply numerator and denominator by cos theta to get integral 0 to pi by 2 sine theta divided by cos theta plus sine theta. This integral can be evaluated by several different methods. However, we will do it by using property of definite integral and that will make our work much easier. As we said, we want to use property of definite integral to do this integral in an easy step. To be precisely, we will use the fact that integral 0 to a f theta d theta equal to integral 0 to a f of a minus theta d theta. We got 0 to pi by 2 and we want integral 0 to a. So we choose a equal to pi by 2. We choose a equal to pi by 2 and f theta equal to sine theta divided by cos theta plus sine theta. And so we can write I equal to integral 0 to pi by 2. 0 to pi by 2. We can copy everything out, but we will replace theta by pi by 2 minus theta. Theta by a minus theta. Sine copied. Cos copied plus sine copied. Just replace theta by pi by 2 minus theta. Once again, Just replace theta by pi by 2 minus theta. Just replace theta by pi by 2 minus theta. Just replace theta by pi by 2 minus theta, and we know that integral do not change. Now we know that sine 90 degree minus theta is cos theta. We know that cos 90 degree minus theta is sine theta. We know that sine 90 degree minus theta is cos theta. D theta copied, 0 to pi by 2 copied. Okay, let's call this to be integral 1. Let's call this to be integral 2. And we add equation 1 and 2. When we add equation 1 and 2, we find I on the left hand side and also I on the left hand side. So we will get 2 number of I equal to integral 0 to pi by 2, integral 0 to pi by 2. In the first one we got sine theta by sine theta plus cos theta, sine theta divided by sine theta plus cos theta. We know that integral of sum equal to sum of integral. So cos theta divided by sine theta plus cos theta d theta. Okay, we can cancel sine theta plus cos theta out, and integral of 1 d theta is theta, and when we write the limit 0 to pi by 2, we get pi by 2. Lastly, we divide by 2 throughout to say that I, the given integral, equal to pi by 4.